Have you ever stopped to wonder what truly makes your smartphone so smart, or how your laptop can juggle so many tasks at once? It might seem like magic, but the real answer lies in something much more fascinating: semiconductors. These tiny, intricate components are the invisible brains that power nearly every aspect of our digital lives, working tirelessly behind the scenes. Semiconductors act as the gatekeepers of electricity, controlling the flow of information and energy. They make it possible for our devices to be both incredibly small and astonishingly powerful, revolutionizing the way we live, work, and play. Before the invention of semiconductors, computers were massive machines that filled entire rooms. Today, thanks to these technological marvels, computers can fit comfortably in the palm of your hand. Every text you send, every photo you snap, and every command you give to your devices relies on these microscopic wonders, making modern communication and creativity possible. Without semiconductors, there would be no internet to connect us, no video games to entertain us, and no GPS to guide us on our journeys. They are the quiet superstars of technology, performing flawlessly in everything from massive data centers to the smallest wearable gadgets. By understanding how semiconductors work, we can truly appreciate the brilliance and ingenuity that goes into every gadget we use. Exploring semiconductors is like taking a journey into the very heart of matter, where we command the elements to perform incredible feats for us. So, let's dive in and discover the amazing science that quietly rules our world and shapes the future of technology. So what exactly is a semiconductor? At its core, it's all about control, the ability to precisely manage the flow of electricity. This unique property is what makes semiconductors so essential in our modern world. Think of it this way: semiconductors sit right between conductors like copper, which let electricity flow freely, and insulators like rubber, which block electricity almost completely. What makes them special is their ability to act as both, depending on how we treat them. This flexibility is their superpower, allowing them to switch between conducting and insulating as needed. Silicon is the most famous semiconductor material. It's not only abundant, making up a huge part of the Earth's crust, but also incredibly versatile, which is why it's used in almost every electronic device you can imagine. Through a process called doping, scientists add tiny amounts of other elements to silicon. This tweaks its properties, letting us control exactly how electricity moves through it, almost like tuning an instrument. This control is a bit like turning a faucet to adjust water flow. In electronics, it's crucial for digital computing, letting us turn electrical signals on and off with incredible precision. Every 1 and 0 in computer code, the language of computers, is actually a tiny switch on a semiconductor chip, flipping on or off to represent information. Modern chips, smaller than a thumbnail, pack billions of these microscopic switches onto a single piece of silicon. It's mind-blowing how much power fits into such a tiny space. These chips perform calculations at lightning speed, powering everything from your smartphone to massive data centers that run the internet. Imagine it as an orchestra of switches all working together in perfect harmony to process information and keep our digital world running smoothly. This precise control over electricity is the backbone of all modern electronics, from the simplest gadgets to the most advanced supercomputers. It might seem like magic, but it's really just the result of some very cool physics and clever engineering. Semiconductors are the invisible force that makes our digital world possible, quietly powering the technology we rely on every day. They're the unsung heroes behind every gadget, every innovation, and every leap forward in technology. Let's see how semiconductors shape our daily lives. Your smartphone is a universe of chips, each with a specific role. From processors to memory, they handle every tap and swipe. Your laptop's CPU and GPU are semiconductor marvels, delivering speed and visuals. Beyond phones and computers, semiconductors power smart TVs, thermostats, and speakers. Even cars are computers on wheels, with chips controlling everything from engines to safety systems. As we move toward electric and self-driving cars, chips will only grow in importance. Semiconductors make our homes smarter and our cars safer. They're the quiet power behind our modern conveniences. Ever wondered how a simple grain of sand transforms into the powerful brain inside your favorite gadget? Let's take a peek inside the incredible world of semiconductor manufacturing, a process that's part science, part engineering marvel. It all begins with silicon, one of the most common elements on Earth. Pure silicon is extracted from sand, melted down, and formed into large, flawless cylinders called ingots. These ingots are then sliced into ultra-thin discs known as silicon wafers, the blank canvases for every microchip. Next comes photolithography, a process that's like high-tech photography on a microscopic scale. Engineers coat the wafer with a special light-sensitive material, then shine ultraviolet light through a complex stencil called a mask. This creates intricate patterns, mapping out where millions or even billions of tiny electronic components will go. But the patterns aren't enough. They need to be brought to life. That's where etching comes in. Chemicals or plasma carve away layers of silicon, following the design left by the light. The result? Microscopic circuits, smaller than a human hair, etched into the wafer's surface. To give these circuits their unique electrical properties, the wafer undergoes doping. This involves adding tiny amounts of other elements like phosphorus or boron to specific areas. Doping tweaks the silicon's ability to conduct electricity, creating the vital on-off switches that make digital logic possible. Throughout this process, the wafers are handled in ultra-clean rooms, thousands of times cleaner than a hospital operating theater. Even a single speck of dust could ruin a chip. Finally, the wafer is sliced up, and each tiny chip is packaged for protection and connection to the outside world. This packaging stage ensures the chip can survive the real world and interface with the rest of your device. All of this happens inside massive, state-of-the-art fabrication plants or fabs. These facilities are filled with advanced machines that operate at the very edge of what's technologically possible, assembling billions of transistors with atomic precision. It's a journey of incredible scale and precision. From raw sand to a finished chip, every step is a testament to human ingenuity, enabling the devices we depend on every day. Semiconductors are building the future, powering not just our everyday devices, but also the most advanced AI systems and supercomputers on the planet. These tiny chips are the foundation of modern technology, enabling everything from smartphones to the most complex scientific research. AI models need immense computational power, made possible by advanced chips that are designed to handle massive amounts of data at lightning speed. Without these powerful processors, the rapid progress in artificial intelligence simply wouldn't be possible. These chips perform trillions of calculations per second, enabling AI to learn, adapt, and grow smarter with every interaction. Their speed and efficiency are what make real-time language translation, image recognition, and autonomous vehicles a reality. Parallel processing allows AI to recognize patterns, analyze huge datasets, and make complex decisions in moments. This capability is essential for breakthroughs in fields like medicine, climate science, and robotics. High-performance computing tackles global challenges with supercomputers that can simulate weather, model diseases, and accelerate scientific discovery at an unprecedented scale. These machines, powered by semiconductors, simulate complex systems, analyze vast amounts of information, and push scientific boundaries further than ever before. As AI and science demand more, engineers and researchers are constantly innovating, creating even more powerful chips to meet the needs of tomorrow's technology. It's a cycle of innovation, where each new generation of semiconductors drives technological leaps, opening doors to possibilities we once only imagined. They're the launchpad for our future, enabling breakthroughs in AI, healthcare, energy, and beyond, reshaping the way we live, work, and connect. Semiconductors are the engines of progress, driving us toward a smarter, more connected world. Semiconductors are crucial on the global stage, driving competition and innovation. Leading in chip design and manufacturing is a strategic asset for countries. The global chip race is about technological dominance and future influence. Chip production is a complex global process with interdependent supply chains. Countries are investing billions to boost domestic chip-making capabilities. This competition accelerates innovation, creating faster, smaller, and more efficient chips. Semiconductors are the backbone of our civilization, powering everything from phones to satellites. They're a testament to human ingenuity, connecting and empowering us. Next time you use a device, appreciate the science and effort behind the chips inside.